Okay guys, let's look at another second order differential equation where again looking at the particular solution. I'm concentrating on particular solutions because once you know how to get particular, then you know how to get general. So we again start with our yc, the complementary function. And to do that, you have to use the original to create a quadratic equation. The second derivative, we'll call it r squared. The first derivative, we'll call it r. Then y will always be 1, so that 1 times 13 is 13. The right hand side will always replace it by 0 because we only use the right hand side to solve for yp, the particular interval. So now we've got a quadratic. So next step is to solve the quadratic. So when you look at this quadratic, it is not the easy type that we can solve by factorization. So we'll be forced to go through our quadratic formula. That's why I always advise students to use the quadratic formula all the times, so that if you make quadratics like this, you shouldn't be forcing it to factorize when it won't happen. So if I'm solving this, my b is a negative 6, so I'll get negative into negative 6 plus negative the square root of b squared, that's negative 6 squared, minus 4, our a is a 1, our c is a 13, divided by 2a. So if we move on, this is a positive 6 plus negative, negative 6 squared is 36, 4 times 13 is 52, so we get 36 minus 52, that gives you the square root of negative 16 over 2. So you see why I said this one is not easily solvable, because with your calculator you can't get the square root of a negative number. This is where complex numbers step in. So this will be 6 over 2 plus negative, the square root of 16, negative 16 will be written as 16 over 2, then times the square root of negative 1, knowing that with negative root of 16 times with negative 1 gives us with negative 16. So the first term will give you a 3, root 16 is a 4, 4 divided by 2 is a 2. The square root of negative 1, from our knowledge of complex numbers, you can call it an I or a J. So from there, if you go now to page 7, you will now be able to write your YC. There will be a formula that is for R equal to A plus negative B I on page 7 of your formula sheet. So your YC will be e to the power A, and A is a 3, e to the power AX, then bracket capital A cos B, your B is a 2. So you get bx plus b sine, or b is a 2, b sine 2x. So that's how you get your yc this time around. So you see that your yc will always depend on the solution of your quadratic, whether your quadratic is complex or 2 equal roots or 2 different roots. So when you're done with yc, you can now switch over to yp, our particular integral. So the choice of yp will always depend on the kind of function on the right hand side. This time around, we are having a constant on the right hand side. So that means your yp is a simple constant. But the procedure doesn't change. You must differentiate your yp 2 times. The first time will give you a 0, the second time will give you another 0. Then you use your yp to replace your y, the first derivative to replace the first derivative, and the second derivative replaces the second. You equate to 39, so then you get your c. So that's what you do. So usually when you have a constant on the right, our work is so easy. So this will be 0 minus 6 into 0 plus 13c, since our y will be replaced by c, which is yp, is equal to 39. And that shows to us that c is equal to 3 if we divide both sides by 13. And therefore, if I go back to yp, my yp will just be equal to 3. And this will show that y, the general solution, is yc plus yp. And that gives us our yc as e to the power 3x in bracket a plus 2x plus b sine 2x. Then plus yp, which itself is a 4. So we'll say y is equal to 1 when x is 0. That's the first condition. What does that mean? It means in this equation, I'm replacing y by 1. Every x by 0, get e to the power 0, a cos 0 plus b sine 0, then plus 3. So if we know our sine and cosine graphs very well, we will remember that cos 0 is 1, e to the power 0 is 1, so this is a, sine 0 is 0, so we just got a plus 3, so 3 is a like term to 1, so if 3 goes there, we'll see that a is equal to negative 2, since we'll get 1 minus 3. Then we can look at the second condition, which will help us get b, which says dy over dx is equal to 1 when x is 0. So again, we do not know dy dx, and whenever we want it, we must go back to the general solution and differentiate. So I'm going to differentiate there. Dy over dx is equal to, don't forget, the general solution is made up of yc plus yp. yc is a product of two functions, exponential and trigonometry. So I must use the product rule. Choose one as u, the other one as v, and I will differentiate using u v prime plus v u prime. That's what we call the product rule. So let's start with u v prime. U v prime means this is my u, which is e to the power 3x. In bracket v prime means I differentiate my trigonometry. To differentiate cos, we get negative 2a sine 2x, then plus 2b cos 2x, since the derivative of sine x is cos x. That is our uv prime. Then we switch over to vu prime. That means I will differentiate e to get 3e to the power 3x. Then my v is captured exactly the same, a cos 2x plus b sine 2x. Then now if I differentiate yp, it gives me a 0. So from here, I can now replace dy dx by 1. E is a 0, x is 0, so e to the power 0 is 1. Sine 0, we still remember it to be 0 from what I explained up there. So, cos, that means this term is part 0, cos 0 is 1. So the first term is a 2b, then we switch to the other, e to the power 0 is 1, cos 0 is a 1, so we'll get 3a, then sine 0 is a 0, so that is our next equation. So continue with that equation, remember that our a is negative 2, so this means we have got 1 is equal to 2b plus 3 into negative 2, so this becomes a 6, which crosses there as plus 6, so we get 7, 6 plus 1 is 7 is equal to 2b, and that tells us that b is equal to 7 over 2. So now that we've substituted to get a and b, we can now write our particular solution. We just go and recopy the general solution, making a negative 2 and b 7 over 2. So that means when y is equal to e to the power 3x, in bracket our a, we are negative 2 cos 2x, our b was 7 over 2 sine 2x, then plus our 3. And that is what we call our particular